So now we have problems number 2 and 3 all on one video for your probability enjoyment. So we have 2 identical containers of marbles, because what could be more fun than identical containers of marbles? Container 1, let's draw container 1, has white marbles and 1 red marble. It has 2 white marbles, so we have a white, and a red. For cup number 2, we have a white and a red. Suppose you select a container at random and then draw out a marble. What is the probability of drawing a white marble? Okay. This one was we really struggled with. So here's what we really want to do. Let's make an area model, because this really reminds me of the investigation where we had the blue and the orange square cubes and you were trying to get no homework. So right away I have to choose cup 1 or cup 2. And so that is a 50-50 chance. So this half of my area model for cup 1, this part for cup 2. If I put my hand into cup 1, I have 3 marbles that are equally likely. I have a white, and a red. Each one of these sections is a third of a half. Well, 1/3 times 1/2 is equal to 1/6. So that means each one of these sections has a 1/6 chance of happening. For cup 2, I only have 2 marbles. I have a white and a red. I have a half of a half. Well, a half of a half is equal to 1/4. So this section, as well as that section, have a 1/4 chance of getting picked. And the question is asking, what is the probability of drawing a white marble? Now, without doing this area model, you are getting this problem wrong. Definitely. So, white marbles. Well, I have 1/6, 2/6. So 2/6 is going to be equal to 1/3, right? So this section here, I have a 1/3 chance of getting. And I have a 1/4 chance of getting this. Okay, well, we need to put these together. All right, so 3 and 4. What number do 3 and 4 go into evenly? Well, 12. Okay, so turn this into 12. So I get 4/12 plus 3/12, and that's equal to 7/12. So I have a 7/12 chance of pulling a white. It's really, really tempting to say 3/5 because there are only 5 marbles. But that's not what's happening because you put it into the 2 cups. All right. Number 3, Tua has created a new game called Making Green. To play the game, a player spins twice, and if the player gets blue in one section and yellow in the other, they win, because blue and yellow make green. The player can choose either spinner of the 2 for their 2 spins. Okay, so then that means I have 3 different situations. I can do spinner A, and then I could use spinner A. I could use spinner A and then spinner B, or I could use spinner B and spinner B. Now, it doesn't matter if I do A first, then B, or B, and then A. It's the same idea. So we need to make area models for only spinner A, 2 spins, 1 of each, and then 2 spins for spinner B. That's just what I'm going to have to do for this problem. And just to double check, first we want to know what is the probability of winning if you spin spinner A once and spinner B once, and then is there a different choice selecting the spinners? They'll get a better probability. So I have to really do all 3 area models. So let's just do them right away. So let's do the AA situation. So we have spinner A. So for spinner A, I could get a yellow, I could get a blue, or I could get an orange or a red on my first spin. Same idea, red, blue, orange. I think I said red, but yellow. And the only way I win is to get a yellow and a blue. Well, yellow and blue happens here. So, blue and a yellow happens here. Are there any other ways for me to win? Huh. No, not really. So in the AA situation, I have 2 out of 16. Well, that's pretty crappy, right? 2 out of 16, that's just 1/8. Huh. Okay. Gotta shrink this, give myself some more room. Let's try the combo situation. So this is the A-B situation. So for spinner A, again, I have 4 different possible outcomes. I have yellow, blue, red, and orange. But for the second spinner, I can't just call this one section equal to the orange or this equal to that. This is clearly 1/2 of the whole thing. And each one of these is sixths. So this would just be 3/6 of the whole. So that means I have 3 yellows as well as a red, blue, and orange. Alright, we want yellow and blue, yellow and blue, yellow and blue, and yellow and blue. So that means I have 4 sections out of, well, 4 times 6 is 24. So that's a 1/6 chance of winning. Oh, well, okay, so this is going to be a 1/6 chance of winning, and my explanation is this chart. Alright. I'm going to lock that in place so that I can just do this. Alright. And so for my last one, I'm going to do the B situation. So this is the B situation. And so again, we have 3 yellows. We have a red, blue, and orange. And same thing going down. Yellow, 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 red, blue, orange. Alright, so we got yellow and blue, yellow and blue, yellow and blue, and then blue and yellow, blue and yellow, blue and yellow. So that's 6 options out of 36. Oh, well, that's also 1/6 as well. So is there another way other than the A-B situation that will get me an equal or better probability of winning? Well, yeah. The B-B configuration will also give me a 1/6 chance of winning. My justification is here. If you're not making area models, you are getting this problem wrong. I can't stress this enough. Okay. On to the next question on the next video.